Annuities, as in many cases, you want to put two things together. You want to understand the key, which is by what factor does money grow each period. It could look like this, or like this, or like this, or like this. This and this, they are examples of elements of R. So they can be seen as one number. So they can be used as K in the geometric series formula. You want to do a timeline, pictures can be useful. Just move things along the timeline using periods correctly until they are at your focal time, your time of focus. Treat separate deposits as independent of each other, and in many cases you end up with a geometric series, so you can apply the formula. Here is a mortgage loan example. It's a 22-year mortgage loan of 156,000. Annual interest rate is 5%. That's to say 0.05, and interest is compounded monthly. We want to find the monthly payment, the total interest, and the outstanding balance after 11 years. Okay, so think in terms of months, months, months. For part 1, use the formula from the formula booklet. Just plug in P is 156,000, R is 0.05, the nominal interest, or the annual interest rate expressed as a real number. The 12th is there, and then R is 0.05. N is 264, not 22. It's 264. This is about 9675.44. If you use calculator, you can go ahead and check it. So that's part 1. Total interest. Well, whatever doesn't go towards paying off the loan must have gone to interest. So you take the total money you paid in, again, months, minus the loan, you get the interest in total. Okay, and finally, what is the outstanding balance after the end of the 11th year? That is to say, at the end of the 132nd month. So that's going to be our focal time, our time of focus. We have a timeline, months, months, focal time. We put out the numbers on the timeline. We make this to indicate that it's, this distance is not 132 times as big as this one. Anyway, the key is the factor. Money grows by a factor of 1 plus 0.05 divided by 12 each month. Be careful. Key with factor, which you find carefully in the timeline. Now just move everything here. So the initial loan size has become 156 times 1 plus 0.05 over 12 to the power of 132, because you move it 132 steps forward. Minus big brackets, all these 132 first payments. This is your focal time. Move all of them to this point. The last one has future value 975.44 trivially. This guy is moved forward 1 step, so you multiply with factor once. This guy, last one, moved forward 131 times, so you multiply with factor 131 times. Brackets, geometric series. This guy stays the same. Starting term times k to the power of n plus 1 minus 1 over k minus 1. Calculator, practice, become familiar with calculator.